I'm James Clokey. I'm the Director of Product Support. I work out of Houston. So pretty much my job is to follow this transmission and engines and everything else that we sell as it gets out into the field to make sure you guys know how to run it, parts guys know how to get parts for it, and our customers know how to operate it. So this is part of what we do, and you'll work with me and you'll work with the guys that work for me. Today what we're going to talk about is the QTR transmission. I would assume you guys have probably seen this or heard of it. We're going to talk a little bit about the insides of it, the outsides of it, how to operate it, how to troubleshoot it, and talk a little bit about the history of the transmission to give you guys some information. There's a lot of rumors, there's a lot of myths out there, so I want to give you guys all the information you have to talk to people about it. So this transmission was designed specifically for the pressure pumping market. It is from scratch. It's not a transmission that was designed for something else and modified for frac. It was designed specifically for frac. It was designed by Cummins. Cummins owns the design. The original intention of this was to assemble this transmission in Seymour, where they build the 19s and the 30s. And that was all started, and we were going and we were into that when the last downturn came about. This project was scrapped. This project was scrapped to make room for other projects that were more pressing at the time, like the 95 liter. So when the market came back up, the demand came back up for this transmission. We wanted to get it back into production, but it was going to be too hard and too long of a process to get it done through the regular Cummins production. So we brought the design and the production to distribution. So this is a Cummins distribution package, but obviously we don't have any place that we can manufacture stuff, so we contracted a third-party company called Desch, and they're out of Germany, and they're the ones that build it for us. So the first couple of transmissions were manufactured in Germany while they built a new facility in Canada, and all the transmissions from then on are built in Canada. And then they've also built a rebuild center in Dallas, right across the street from our rebuild center. So as we get more of these in the field and they come up for rebuild, they'll be rebuilt right there in Dallas, just like our engines. Right now, it is rated for 2,500 horsepower, hence the name QTR2500. The mounting arrangement is designed right now to be mounted on the QSK50 only. We're working on mating it to MTU. We've got a lot of demand to put it on an MTU to replace some competitive transmissions. And then we're also working to get it onto a QSK60 at 3,000 horsepower. Life to overhaul is equivalent to the engine for this transmission, excuse me. So some of the features of the transmission we'll talk about. First of all is there's an external disc brake. Some transmissions have an internal brake, which you think about that. If you have a brake issue, you've got to disassemble the transmission to fix it. Ours is external, so it's easily serviceable. The brake is not there to bring the transmission and the engine to a halt. It's there to hold the pump. So the brake will not hold the engine. If you could put the transmission into gear with the brake on, it'll turn right through that brake and it'll smoke the brake. The way the controls are set is if you go to put it in gear, it releases the brake, but if there was a problem, the brake won't hold it. It's just there. It's a parking brake like in your car, the hand brake in your car. Another feature is there's a barring device on the back of the transmission. It's just similar to the barring device on our engines. And it is there to turn the transmission only. It won't turn the engine, it'll only turn the transmission, it'll turn the output shaft of the transmission. And that's there for the pump guys, so when they got to do service on their pump, they can rotate that barring device to turn their pump to do their valves and seats rather than using a big pry bar in the drivetrain, in the driveline like they have been. And it's just like the one on the engine. It's got the little locking pin. You pull the pin out, you shove it in, you turn it, and you pop it out to disengage it. And then the transmission has its own control module. That control module does talk to the engine over the 1939 data link, but it is its own independent device. So it takes inputs from the frac rig for desired gear and desired throttle, and it talks to the engine ECM, tells the engine ECM how much throttle it wants, and the engine throttles according to that. Data of it, again, 2,500 horsepower. There are 8 forward gears in the transmission plus a test of pressure system gear. There's no reverse in the transmission, it's only forward gears. It's the same warranty as the engine, 2 years, 2,000 hours, unlimited in the first year. It's a dual clutch transmission, no torque converter. Okay, it's a manual transmission, manual gearbox, but it's all shifted automatically. The transmission weighs about 7,300 pounds, and it uses the same oil as the engine does. So same fluid, you don't have to have a separate fluid for it. Gears, gear ratios, put that up there just to show the tops. So then we'll talk a lot more about tops as we get on, but you notice all the forward gears, it's a real nice even split, real close ratios, so we can shift gears under power and keep the engine in its torque curve, real smooth even shifts. And then the tops gear is a very, very low gear, and we'll talk more about that in a minute, what it does. Okay, transmission data plate. There's 3 locations on the transmission where the data plate could be, because we like to keep things interesting. Original idea was to put it up there, and then they decided to put it back there, and finally on the back. So that back position is where you should see the most of them, but on some of the earlier ones you'll see it up there on the front. The transmission data plate, it is the dash data plate. On the early versions, on the later versions, it's a Cummins data plate, but it's got the transmission serial number. Transmission serial number is just like any other Cummins serial number. It's an 8-digit number, but it's a 009 and then everything else. So it's a DBU serial number. Okay, we'll talk about field support. So there's a lot of money tied up in development of this transmission, and this is very high on the radar from upper management. This project will succeed, it has to succeed. And in order for it to succeed, the one thing we need is help out in the field. We need you guys out there. It was easy at first when we had one out in the field for me and my team to go out and support it, or the engineering guys, but now that we've got more, it's too much. So we need more guys. And the purpose of today is this is not a full-on, you're not going to be a certified transmission technician at the end of the day. I'm just going to try to give you guys enough knowledge to where you can plug into it with your computer, you can communicate with it, read fault codes, see operating parameters on the laptop and know what the transmission is trying to do, what it's telling you. And then also basic troubleshooting, so you know where sensors are, you know where pressure valves are, and you can change parts and pieces if you need to. And then also if you're out troubleshooting them, you know what to look for. So if we ask you, hey, you need to go look for this pressure relief valve, you know, you've got an idea where it is, and you can feed back information to us so we can remotely help you keep them going. For right now, the only repairs that are going to be made to the transmission are external repairs. So oil leaks, failed sensors, failed valves, stuff like that. If we have a part break inside the transmission, inside the gearbox, we're going to swing the whole transmission. We've got 100 of them sitting in Arlington. We've got plenty of spares. The only exception right now for this is the clutch, and we are going to start doing clutch work in the field. It's too much of a job to do out on a location, so in the field we mean at a shop. So if we have a clutch failure, we will bring it to, say, to this shop. We'll pull the transmission out and change the clutch. We're either going to change just the clutch assembly itself or the entire clutch housing, depending on what's quicker and easier and what it needs. There's no tools, no special tools needed to work on it until we get into the clutch. The only thing about that is pressure gauges to check hydraulic pressure in the transmission. The oil pressure in the transmission is 500 to 600 psi, so you don't want to be using your PB350 or a 0 to 100 psi gauge. We need to get higher pressure gauges, but we'll talk about that later. Parts are in stock. Parts are in stock here in Odessa. Oil filters, O-rings, breathers, position sensors, all that stuff we have in Odessa. I have a parts list made up. I'll email that to you guys. So everything that we can change, we have in stock, and it'll have a part number and a description for you. It's not on quick serve yet. It's being put on quick serve. But since it's such a small number of parts, it's really easy to keep track of. Any parts that you change, we need to know about it, and we need to have the parts back. It's all infant care stuff, so even an O-ring, if there's a cut O-ring, we're probably going to want that O-ring back to try to figure out what happened to it. Procedures on QuickServe Online, there is a maintenance, troubleshooting, and repair manual. There's wiring diagrams on QuickServe Online. We'll talk about how to get to that later. Electronic service tools. This is the PuTTY software, which is on your laptop. Before you guys leave today, we'll get all your laptops set up, and you'll plug into that transmission and go through everything, and I'll show you how to work it. There is a communication cable that's needed. W0271 is our part number. You guys have 2 of them here in Odessa. Waylon keeps them in his office. So if you need to go work on a transmission, you have to get that from him. Calibrations are done through a different program, and for right now, we're gonna leave that till later. We're not gonna do any calibrations in the field yet. All right. Now we'll start getting into the parts and pieces. Okay, transmission housings. So the gearbox of the transmission is made up of 4 housings bolted together, externally bolted together with lots of bolts, hundreds of bolts. When we go out there and look at it, there's an incredible amount of bolts holding this thing together. All the housings, all the seals at the housings are sealed with anaerobic seal and O-rings for oil passages. There's no gaskets. The only gasket on this transmission is the oil pan gasket. Clutch housing is a separate housing, bolts on the front. As the name might imply, that's where the clutch lives. But also, there's 2 PTOs that drive out of the clutch housing. Terminology for all this stuff still isn't decided on, so right now we're going by numbers, the drawing numbers, and the clutch housing is H99. So if you talk to engineering and they're trying to get you to look at something, they're going to tell you to look at the H99 housing. That's the clutch housing. Next housing going back from that is the tops housing. Going back from that is the filter housing, H72. Next one back from that, H73, the fill housing. That's where the oil fill cap is up on the top. It's the name, fill housing. And then the back housing is the output housing. Okay, looking at the left side of the transmission. So there are 4 lifting points on the transmission, 2 on each side. And you can use the same fixture that you use for the QSK 50s and 60s. It'll clamp right onto this thing and pick it up. Mounting locations, 1 on each side. This is where the cradle that supports the transmission bolts to the transmission, and from there it bolts down to the frame of the rig. Sight glass. So no dipstick on the oil pan. There's a sight glass. The sight glass has 4 different locations, 1 on each corner of the oil pan. And our standard is on the left side rear, but depending on the customer, they might move it around to make it more accessible. Transmission control module, TCM, is mounted on the left side. And then the customer connections. So right here, this is where the customer lands their power and their communication and everything else, and this is also where you will connect your laptop to it. And both of these are pretty easy to get to on every application that I've seen so far, other than one up in Canada. You don't have to worry about that. Okay, back side of the transmission. The only thing back there really worth talking about is the brake. It is a twin disc or twin caliper brake, disc brake right now. They are looking into going with a single caliper. There's the barring device on the right bank side of the transmission. The oil drain plug is on the bottom of the pan at the rear. And then there's 2 oil heaters. Those come standard in the transmission. Every transmission has them. We don't connect them. The OEM connects them, and those connect to the engine coolant. Okay, the right-hand side, customer oil connections. So oil out of the transmission to the cooler comes out of that big pipe at the top, goes through the cooler and returns to the clutch housing and dumps at the pan up there in the front. Oil filters. It's got 2 oil filters. These filters are high pressure, so they are gear pump pressure, 500-600 psi in those filters. So special care when you change filters. And obviously you don't want to try to take one off while it's running. 2 breathers on the right side of the transmission, right below the oil filters. And these are a serviceable item. We have them in stock. And then the mounting feet on that side. Okay, and then looking at it from the front, there's 2 power takeoffs. The power takeoff on the left side is the customer mounting PTO. That's where the customer will mount their hydraulic pump to drive their fans or whatever they need to on the unit. And on the right hand side is where our oil pump is. Each PTO is capable of 150 horsepower load. So they can pull a full 150 horsepower off the left side. We're pulling 50 for our pump. So they've only got 100 horsepower left on the right hand side. The pumps mount onto the PTO. It's a dry mount. So it's not a lubricated spline. There's no gasket, there's nothing in there, and we have seen some indications of some wear on some of the early ones. So that might be something that we're asking you guys to do on some of these first few, is to go out and pull those pump backs, grease the splines, put them back on. We'll talk about that when we get out there. The pump is light, it's real easy to get off, it's not a horrible job. And then the input shaft goes into the flywheel. Okay, manifolds, talk about the manifolds. This is a hydraulic manifolds. This is where all the oil gets distributed in the transmission, through the transmission. All the actuators, everything happens through all these manifolds. There's 8 of them. We'll go over them real quick on here, and then we'll go look at them out on the transmission here in a bit. So the first one is the clutch manifold. It lives up on the clutch housing, bolts right up on the top of the clutch housing. All the valves on it. There's 2 valves up, the 1 and 2 there, that's clutch cooling. Big valves, high volume of oil, so push a lot of oil through the clutch when we're engaging the clutch to try to keep it cool. It's going to get really hot really quick. We'll pour a lot of oil through there. Clutch pressure, clutch 1, clutch 1A, and 1B. This is the actual clutch engagement pressure. So the clutch is actuated hydraulically. So this is the oil pressure that's actually engaging the clutch. So you can have one of those pressure sensor fails. You will get a fault code for it, but it will continue to operate because it's got the other sensor. Dump valves. So we actuate the clutch with oil. The oil stays in the clutch to keep it actuated. When we want to release the clutch, we need to release the clutch really fast. We don't want it to drag, we don't want it to slip. So that's what those dump valves do. They open it up and they just pour the oil and it drops right straight back into the sump. Clutch pressure valves, I already talked about those are redundant. And then these are the actual actuators. These are what actually turn on to pour oil to the clutch to engage the clutch. Okay, the next one is the lubricating oil filter manifold. So this is what's going to receive the oil straight from the oil pump through those filters and then into this manifold, and then from here it's going to go off everywhere else. There's some pressure sensors in here, some temperature sensors. We'll look at all of that, and then some release valves to control maximum pressure of the system. Synchronizer manifold bolts right behind that manifold, and these are your first shift fork actuators. These are what's actually going to drive your shift forks to put you into one gear and out of another gear. There's 5 shift fork actuators, so there's 5 shift forks, excuse me, so there's going to be 10 actuators. 9, 1 in, 1 out, except for tops, and it only has 1. Okay, brake manifold goes on the back right above the brake. It's got 2 more shift fork actuators, and then it's also got, it controls the oil to the brake. Tops manifold sets on top of the tops housing. 2 more shift fork actuators, and then the tops shift fork actuator. Lubricating oil pump manifold, it sets on top of the oil pump. Pretty much the only reason that's there is the oil pump has 1 single outlet. This manifold divides that up into 2 outlets, a hose connected to each one going to each filter. relief manifold. So this is where the oil comes out of the cooler, the customer transmission oil cooler, dumps back into the transmission. Okay, oil pan. Again, bolts up to the bottom. It has a gasket, pretty much the only gasket in there. And it's got 2 heaters in it. Every transmission's got those heaters. And there's also a lubricating oil temperature and level sensor on the back of the oil pan towards the bottom. We look at oil pressure. We log a lot of faults for our oil temperature. We'll talk about that. We'll look at that on the computer. And also oil level. It is an actual 80, 90, 50, whatever percent oil is what it's showing. And it will shut it down for oil level. Talk about some of the sensors, speed sensors. On the right side of the transmission towards the rear, that's output shaft speed. The right hand side of the transmission to the front, that's the right hand shaft speed. The other side of the transmission is the left hand shaft. There's 3 shafts in the transmission. We'll talk about that later. And then pressure sensors and temperature sensors up on the header. Some of these sensors will move around a little bit from early transmissions on into production. So what you run into in the field may not be exactly like this, but the harnesses are marked really well, and all the manifolds are stamped really well. Everything that goes is stamped in there. So it's pretty easy to trace. Shift fork position sensors. So there's 5 shift fork position sensors. We're going to spend a lot of time talking about these. We have had some problems with these. And there's some confusion as to where they go and what they do. So the right-hand side of the transmission, the shift fork position sensor at the front is R1, R2, and that is the shift fork and the synchronizer. So when we refer to a synchronizer or a shift fork, it's R1 or R2, 3, 4, 5, 6, 7, and 8. 3 and 4 are on the rear, 5, 6, 7, 8 are on the other side, and they're all 3, 4, 5, 6, 7, 8 are all front to back. 3, 4, 5, 6, 7, 8. 1 and 2 is backwards. So 1 is the back and 2 is the front. So that can be confusing. It'll make more sense when we look at it on the computer. And then the TOPS shift fork position sensor, it's on the left side of the transmission to the very front. When you're plugged into the TCM on your laptop and you're reading shift fork position sensors, the range is minus 100 to positive 100. So it's full travel one way is minus 100, full travel the other way is plus 100. Right in the middle would be 0. The right-hand side of the transmission, when the shift forks are to the back, that'll read minus. If they're all the way to the back, they'll read minus 100. All the way to the front, positive 100. It'll be the opposite on the other side. There is a little bit of over travel, so when we engage the shift forks, they push all the way to the back to 100, and then they'll relax a little bit. And their actual holding position will be 97 or minus 97. So when you look at it on the computer, that's what you want to see is minus 97 or 97, depending on where it is. And if it's not there, that's telling you something. We'll talk more about that later on. You can calibrate them, you can move them around, and tear a lot of things up if you're not careful. So we'll cover that a lot. That's the one thing about this. When we talk more about the putty and the programming, it's not like Insight where it's designed where you can't tear things up. You can tear this transmission up with putty if you go to the wrong screen and do the wrong thing. So I will spend a lot of time telling you what not to do as well as what you can do. So what we'll do now is we'll hop up, we'll run out there and we'll take a walk around the transmission. We'll talk about all the things that we've looked at so far. So obviously the input side, there's a coupler, a Geislinger coupler, which is pretty much the same that everybody else is using, the same that the competitive transmissions use. That bolts to the flywheel housing, and we simply just spline into that. Nothing at all tricky about it. It is a wet housing, so there's an O-ring goes around here. All the oil from the cooler, the clutches, and everything else dumps into here and then drains back to the sump. So there's a lot going on in here. There's a lot of oil. This is the input shaft here, connected to the crankshaft of the engine. Inside, this is the PTO drive gear, and there's a PTO idler gear on either side driving the outside PTOs, and then the clutch is further on in the back, both clutch packs. So again, this is the H99 housing from here back. So this is a serviceable part. These bolts right here, you bolt all of that, swing this thing right off. There's a plate right here, cover plate. This is where you go in to do clutch inspections. And this is part of the normal procedure that we'll probably be asking you guys to do on some of these. We're gonna be looking for signs of heat, signs of the clutch burning, and then we actually measure the gap in between clutch plates. This is the customer PTO pod. This is a PTO pod that the customer will connect their lube pumps to, or anything else that they need to drive off of it. On the left side of the transmission, this is the customer connection point. Customer power and inputs for gear selection. Throttle comes into this bottom. There is a ground that connects to the inside, and then our service diagnostic tool connects into the harness right there. J1939, you can plug into here, you can talk to the engine from here, you can talk to the transmission if we had that software. And then right behind that is the TCM, that's the transmission control module, the brains of the outfit right there. So H99 clutch housing, H71 tops housing. The tops gear is in here. This is the tops position sensor. H72 housing, oil housing, filter housing. This is R5, R6, shift fork position sensor. And there's a inspection plate here. You can pop this up and you can see the synchronizer in there. This is something else that we will ask you guys to do at some point along the way for troubleshooting and also just for wear analysis as we see where we're going. R7, R8 shift fork position. The output shaft are twin brake calipers. Brake manifold right here. There's the fill housing where they put the oil in. There's your oil level. The barring tool that we talked about right there. Pop that pin out, put it in there, turn it, just exactly like the engine barring tool. R3, R4 shift fork position sensor. Output shaft speed sensor. Oil filters. Crankcase transmission breathers. R1, R2 shift fork position sensor. This one is reversed. This one reads back to front. All the other ones are front to back. So 1, 2, 3, 4, 5, 6, 7, 8. This is oil out to the transmission oil cooler. Oil goes through the cooler, returns back to the transmission through this fitting, dumps to the oil pan. This is our lube pump. Our lube pump's driven off the right side PTO pod. This provides hydraulic pressure and lube oil pressure to the transmission. If there's a failure in here, we do stock these. You can just change this. Don't foresee anything happening there. But again, this spline in here, it is a dry spline. We have seen problems with that. So there is a grease that we've identified that we're going to put on there. And we may need every couple of thousand hours to pull this pump off, grease that spline up. These steel lines across the top, these are all your actuators. So this is the oil that's pushing the piston to drive a shift fork actuator in and out. Everything's done hydraulically. All the harnesses, every connector is marked. It's a good steel plate that's easy to read. Depending on who puts it together, it may or may not get painted over. If they mask them off, it's a real easy way to find it. So we're going to look inside. We're going to talk a lot more about what's going on in what gear, where shift forks are, all that good stuff as we're going through gears. And the other thing I got is, I got this video. I took this video in a test cell with a customer a couple years back. And I threw this in there just to kind of give you a sense of what this thing sounds like. There's a lot of gear whine with this transmission. That's normal. And also to see what it's like when it shifts. So this is a gear shift going from second gear to third gear with about 10,000 psi against the pump. If you've ever pay attention on a frac pad and you'll see some of these competitive engines, you can tell when they shift gears, you can hear the clunking and the banging, and you can see the trailer rocking back and forth. All that clunking, all that banging is hard on drive lines, it's hard on pumps. So we don't do that, and that's one of our advantages. So so did you hear the change in the gear whine? The pitch of the gear whine went up higher? That was the gear shift right there. But other than that, there's no rocking, there's no clanging, there's no banging around. It's really smooth. But you will hear, with the engine idling, the transmission, there's quite a bit of whining. You can hear the transmission over the engine, over a QSK50. So some people kind of freak out about that, but it's normal. So orientation, when we talk about the transmission, it's exactly the same as the way we talk about engines. If you're standing at the back of it, on the output side of the transmission, left is left, to right, left bank, right bank, just exactly like the engine. And that's how I'll refer to everything as left bank or right bank, because that's how I was raised and that's what makes sense to me. Shafts, so it is a dual A shaft transmission. So there is one common shaft through the bottom, that's the input and the output, and then there's a lay shaft on either side of that. The input shaft receives the torque of the engine through a Geisinger coupling. We just saw that. Goes through the transmission, through the gears, comes out the backside, and powers the load. Lay shafts. So parallel lay shafts, one on each side of the transmission. The left bank side of the transmission is the odd gears. The right bank side of the transmission is the even gears. The shafts are, it's not really one shaft all the way through. It's really two shafts split in the middle. Okay, and on the left side, the odd gear side, it's split in the middle, and there's a bearing supporting the front of that one and the back of that one. This shaft is not connected internally. Okay, the only thing that connects this shaft is all the gears. The right bank side it's split just like the other one is. The rear shaft is a hollow tube with splines on the inside, and the front shaft is a shaft with splines on the outside, and the splines inside of each other. So they are mechanically splined together. And all that will make more sense why as we get further into this. Okay, dual clutch. You'll hear that a lot, is dual clutch transmission. There's two clutches. They're referred to as K1 and K2. K1 is the big clutch drum that you see on the outside there. So K1 drives the right bank side. K1 drives the even gears. K2 is the smaller clutch on the inside. K2 drives the left side. K2 drives the odd gears. So when we shift from an odd gear to an even gear, first gear to second gear, there's no gear changing that goes on. All we're doing is switching from K2 clutch to K1 clutch. And it's a instantaneous change. Release one right as the other one grabs. So that's why you don't see the rocking and the banging. You saw that nice smooth shift. And it happens in half a second. This is the same concept. I don't know if any of you guys watch Formula One racing. Real fast paddle guys. That's the same concept. Or some of your newer passenger cars, Audis and the Volkswagens, the DSG transmission. That's what that is. It's a dual clutch. It's the same design. The only difference is with them, they're pre-selecting gears up and down. They're looking at throttle. They're looking at everything, trying to figure out, you're in third, you're going to go to fourth, you want to go back to second. Whereas if we're in first, we're going to second next. Right? We're not going to skip up. We're not going to go around. Everything is 1, 2, 3, 4, 4, 3, 2, 1. So looking at the clutch with the housing off, the clutch drum, the big drum on the outside, that's your K1 clutch. The K2 clutch inside on those splines inside there. The clutch sitting out on the floor, same thing. The big one, that's K1. The smaller one, that's K2. And then looking at it through that inspection window that I showed you guys on the front, this is the K1 clutch right here. So those right there are the K1's clutch discs. And then looking through that hole into the K2 is the K2 clutch disc. And that's what they look like looking through the hole right there. And we'll go out and we'll pull that cover off and we'll look at it, because that is part of a maintenance procedure, is to measure this gap in between these clutch discs. And there's a specification, and we have a tool to do that. Shift fork synchronizers. So this is when we talk about R1, R2, R3, R4. This is what we're talking about. Looking through the little inspection window on the side of the transmission, this is the synchronizer inside of it. This bronze pad right here is what rides on this clutch fork or shift fork, and that rides right inside this ring, and that pushes this synchronizer ring up onto this spline or down onto this spline to engage that gear. Synchronizer identification. So we talked a little bit about this. So they're all simple front to back except for R1 and R2. R1 and R2 is reversed. So there's R2 back. So if you're looking at that on putty, that's going to be minus 97 where that's setting right there. And this one's going to be minus 97 where it's setting right there to the back. R1, R2 on the right, R3, R4 on the right rear. 5, 6, 7, 8 on the left, and the tops at the very front. Same thing, but this is looking at them from the outside. So we'll start talking about what's going on when we're into a gear, going into a gear. These drawings are really only half accurate. And the reason they're drawn like this is because it's showing us what this side is doing while we're going into first gear. It's not showing us what this side's doing when we're in first gear, because it's going to be different whether we're coming back into first from second, or if we were in third gear coming from fourth. This is going to be a different spot. So I'll try to walk you through it without confusing it much more, but for right now we'll just look at it as it's drawn, and I'll explain more later. So for first gear, both the shift forks are going to be to the rear. Actuators are going to push both shift forks to the rear, to the 97 position. We're going to engage K2 clutch, and that's first gear. So looking at it from the inside, this is the R5, this is the R6 gears. So that's your first gear, that's fifth gear. There's your shift fork to the back. And then when they come out of the transmission, you just hook a hoist onto them and they lift right straight out. They're just setting in there on bearings. And also just kind of notice as we go through this, the size of these gears. That's why this thing weighs 7,500 pounds, but this is all one of the reasons why we're not too worried about making internal repairs. This thing ain't gonna break. So second gear, we're gonna shift from first gear to second gear. Really nothing is going to change in the transmission. Shift forks are going to be at the back. And then all we're going to do is switch from the K2 clutch to the K1 clutch. So we'll drive this other side. So first gear to second gear is nothing but a clutch swap. Nothing else happens in the transmission. When you start the transmission up and it builds hydraulic pressure, the transmission goes to what it calls a home position. And the home position is all 4 shift fork sensors are to the back. So all 4 shift fork positions to the back, that's ready for first gear, okay? And the clutches are released, so this is neutral. So when you command neutral, and it says it's in neutral, the transmission is actually in a gear, but the clutches are just released. So we don't really have a neutral position. We don't shift the transmission anywhere to neutral. We just release the clutch. And that's kind of important to remember, that home position. So when we first started up, it's going to be, they're all 4 are going to move to the back. And so that's first gear. It's ready for first gear. So these are to the back, and these will be to the back. And then both clutches are released. So then we'll energize K2 clutch, which drives the left shaft. So that'll put the power through the left shaft. That's first gear. And then when we want to go to second gear, all it does is it releases the K2 clutch and engages the K1 clutch. Literally, I mean, almost at the same time, in the same instant. And it just changes over from one to the other. So when we go to third gear, it's going to start off in first gear, go through first gear, go through second gear, and then when it's in second gear, it's going to start to pre-select third gear. This is the R1 and R2 gear set. It's the R1 gear, that's the R2 gear set. And then you kind of get an idea here, you can see, right, everything's splined or meshed. All these gears are always meshed, everything's meshed together all the time. So if we're in second gear, and we select third gear, so if we're in second gear, I'll shift fork positions around to the rear, right? We're driving on K1 clutch. So what the TCM is going to do is it's going to start to tap the K2 clutch to slow down the K1 shaft, because the K1 shaft is still in first gear, so it's spinning a lot faster, right? Because to do 10 miles an hour in second gear, right, 2,000 RPM would be 4,000 RPM in first gear, right? So it starts tapping that clutch to slow that shaft down. And then when that shaft gets to the speed that it needs to be in to move the synchronizer into position, then it commands oil pressure to that R5 synchronizer, and it pushes it forward. And then once it sees that R5 is forward, it's in minus 97, then it releases K2, energizes K1, and you're in third gear. So if the operator commands second gear, it's going to shift first gear, second gear, and then it's done. It doesn't care, right? If the operator commands fifth gear, then it's going to shift first gear, second gear, and then while it's shifting into second gear, it's going to start working on getting third gear ready, clutch tapping, synchronizing, and then it's going to shift over. And depending on the gear, on what's happening, some gear shifts happen really quickly. Like first to second, it's just going to be a clutch swap. Boom, it happens. Second to third, now we've got to move that one shift fork, so it takes a couple of seconds to synchronize. So you'll have a real quick first to second, second to third will be a little bit longer, third to fourth will be a little bit longer, on down the line, depending on how much stuff it has to move around to synchronize. The actual gear shift it's always just like that video. It's instant, right? Half a second. But the time that it takes to get everything synchronized could take 2, 3, 4, 5 seconds, depending on what gear it is and what the load's like. Some of the operators, they're pushing third gear, they're used to first, second, third, fourth. You know, the way those automatic transmissions to shift right up. And this will be first, second, third, fourth, and sometimes it takes a little bit of getting used to. The downshift under power will happen just like that upshift. Just as smooth, just as seamless. It happens instantly. A downshift from, say, fourth gear to neutral, we just release the clutches. We don't step back down through the gears. But yeah, upshift, downshift, it's just as smooth. No clunking, no banging around. So to go to third gear, we just went to the K2 clutch. We moved R5 to the forward position, then we engaged the K2 clutch. So all we do to go to fourth gear is now we're wanting to drive the other side, right? So we're going to move R1, R2 forward into the R2 position. So now it would be reading 97 if you're looking at it on putty. And then we're going to release K2 and engage K1. So first through fourth gear, first gear, all the shift fork position sensors back. Second gear, they're all back. Third gear, R5, R6 moves forward. Fourth gear, R1, R2 moves forward. And then it's just clutch swaps back and forth. And this is pretty much everybody. That's what they're going to run through, first and fourth gear. I don't think anybody ever uses the gears higher than that, other than sometimes maybe when they're clearing out pipe. So now to go to fifth gear, now we're on this shift, we're moving 2 shift forks. So we're moving R5 and R6, which was up in R5. We're moving it back to R6. And R7 and R8, which was back in R8, we're moving it up to R7. So that takes a little bit longer, a lot more oil, a lot more stuff to move around, plus we're synchronizing 2 different gear sets. So this is a longer shift. Fourth to fifth is a longer shift than any of the other ones as well. And then the gears in the back, so R7 and R8 gears back there in the back, shift fork position, the output shaft. And then you can see on the other side, you can see that tube, that shaft, or the other one couples inside of it. Or these 2 shafts, the one that would go up here, they're not mated together, it's just a bearing right there. But again, big, beefy stuff. Okay, 6th gear is the same as 5th gear. We're just going back to the other side now. We're moving both shift fork positions, we're swapping clutches. Same thing on the other side. Again, you'll notice all the gears are all meshed all the time. Shift forks right here. And then this right here, these are spray bars. Every gear's got 1, 2, 3, or 4 spray bars, just like a piston cooling nozzle. All those gears, all those bearings, everything is flooded with oil all the time. It's a massive amount of oil that goes through this thing when it's running. 7th gear, same thing, just popping back to the other side. But now we're just moving R5 back forward. So this would be a little bit faster shift than going into 5th gear was. And then the last one is 8th gear, same thing. All right, so the next one is tops. We've talked a lot about tops, or I've said tops 100 times, but I haven't told you what tops is. So tops is, it's its own special gear. It's the gear that we use to pressurize the iron. So when they hook up all their stuff to the well, before they do anything, they always pressurize everything, make sure they don't have any leaks, right? And the normal procedure for that is that they want to pressurize, say, to 10,000 PSI. The operator will put one transmission in gear and he'll wait until the pressure comes up, right? And then he'll go to neutral, like at 8,000 PSI, right? And then he'll go back into first gear and then back to neutral, and he'll neutral first, bumping it until he gets up to whatever he wants, just 10,000 PSI. It takes a lot of time to do that. It's hard on the transmission to do that. It's hard on the pump. It's hard on everything to do that. Neutral first. So what this does is this is an automatic pressure system. So if they want to use this, the operator goes into his screen and he finds the test of pressure screen. He selects that, he inputs what he wants, say 10,000 PSI, and he pushes start. And then the transmission does it all by itself. And what it does is, using the K2 clutch, it engages this tops gear, this tops shift fork. And then it also puts R7 and R8 in neutral. So this is the only gear, this is the only time this transmission ever operates where any of these 4 shift forks are in a neutral position. And the reason that this is in neutral right here is because we're actually running both these shafts at the same time. And if this one wasn't in neutral, it'd cage the transmission, it would bind up. Okay, so we split this shaft into 2 right here. So this gives you a 16-to-1 gear ratio. You enter your test pressure, 10,000 PSI, you push start, it shifts that, it rolls everything, and then once it gets closer to the pressure, what it does is it releases the clutch and it just kind of starts bumping the clutch and brings it all the way up to 10,000, and then it shuts off and it goes to neutral. It literally it can turn that output shaft like a quarter of a turn at a time. You can sit there and you can watch it and it'll just bump that output shaft. It's really slick, it works really well. And then again, once it's done, it shifts to neutral. And remember, neutral is all 4 shift fork positions to the rear, minus 97 to 97, and then the clutch disengaged. What we have seen sometime, they'll do this tops mode, and then they'll want to go to work, they'll go to shift it, and they won't go into gear. And what's happening is this R7, R8 is staying in the neutral position. Okay, the TCM is going to command this into gear 3 or 4 times, and if it doesn't go, then it's going to stop. It just basically gives up. So at that point, if you go out to one of these and they say it won't go into gear, and you plug your putty in and you see this R7, R8 is hanging out at 0 or 10 or 15, something like that, it's in neutral. Probably what happened is they used the tops mode. Once they got done with the tops mode, for some reason that didn't go back into gear, so the transmission locked itself out. At that point, the only way you can get it to reset is to shut it down, power it down, and then start it back up. And when you start it back up, it'll drive everything back home. I wanted to kind of to beat that one home. If you see R7, R8 in neutral position, that's probably what happened. It won't give a fault or anything like that. It just won't go into gear. Customer call you, it says it won't go into gear. You can ask them, did you try to use tops? Yeah, we used the tops and it wouldn't go into gear. Okay, shut it off. start it back up, and it'll probably work. So this is the top gear right here, drives it through an idler gear onto the other shaft. So when this is released, when this is in its neutral position, this is all just free spinning. And then when this engages, then it engages this gear through this idler, you know, and then it drives this gear back in through here onto the other side. That's where you get that 16-to-1 gear ratio. It's a really, really low ratio. When they do the test mode, the engine's at idle. They do it at idle, yeah. We'll go over a little bit more of this in the operation part, but yeah, to enter the tops mode, the transmission they have to be in neutral to start with. It won't go into tops if there's any output speed of the tail shaft. And normally we don't have any output tail shaft speed. A lot of your automatics, you know, that output shaft's always turning unless you set the brake. This one, it won't. When it's in neutral, nothing's going to be turning out the back. Once we get some wear on the clutches, the plates warp a little bit, we'll get a little bit of drag, and you might see some output shaft. So at that point, the tops won't engage. So what we're trying to get everybody used to and all the controls is to go to neutral brake. For tops to work, they have to go to neutral brake first, set the brake, that stops everything from turning. Then it'll engage the tops, release the brake, and but it all happens at idle. If they throttle it up, it's going to kick the transmission to neutral. It's all automatic. As soon as they push that test to pressure mode, they set their pressure, they push start, that's all they got to do. Everything else happens all by itself. What we'll do, we'll take a little break, take about 15 minutes or so. All right, guys, so we're going to do a little quick hands-on exercise here. What I'm going to get you to do is first pull the R5, R6 inspection plate off, and then tell me what position that shift fork's in. And then we'll pull that sensor off, and then we'll pull the clutch cover off and look at the clutch. So grab your wrenches, go to R5, R6, pop that cover off. So that pops right off. That is a more or less reusable gasket, assuming you don't tear it up. So now if you look inside there, what position is that shift fork in right now? Yep. So you're both right. So it's at the rear, right? It's in the back. So that's 97. R5, R6. So that's in the R6 position right now. So assuming that we engage the K2 clutch, and assuming that this shift fork is also at the rear, that's first gear. And then we just swap to that side for second gear, move this shift fork up to here, and then engage the K2 clutch, and that's third gear. That's what everything inside here should look like after it's got 10,000 hours. That's what it's going to look like. Things that we might see is there are little clutch discs inside that synchronizer. And that's how it works, by smashing those clutch discs together and slowing everything down. If there's a problem with the shift fork holding that synchronizer up against the gear instead of being in the release position, it would overheat that, and you'd see signs of heat in there. So they'd be turning blue and purple and all kinds of crazy colors like metal does when it gets hot. And the same thing with that bronze pad right there. You'll see black, blue, all kinds of colors like that if it gets hot. And that would be signs of a problem. So, okay, that's that. Go ahead, slap that back up. Just leave it kind of snug so the next guys don't have to fight with it. There is a torque spec for those bolts. It'll be in the literature that I can share with you guys. But I would recommend you torque those to spec unless you're really good with your impact. As we did on the prototype transmission that we tested, we found that plate warped after a while from the guys hammering it in with the impact, and then it leaked. All right, so let's go ahead and pop that R5, R6 shift fork position sensor out. Okay. All right, so you see, obviously that's sealed with an O-ring, not a gasket. If you're going to go out and you suspect you're going to be doing something with these position sensors, take a gasket with you. Those tend to, after a while, they swell up, and then you never get them back in. And then you'll notice that they are doweled, right? So they'll only go in one way. You can't get them in there backwards. And so all this is this is your shift fork right here, and that's a magnet that's bolted to the top of the shift fork, and that's what that reads. That reads that magnet sliding across this. So there's your 150 minus 100 all the way across. Yeah, and that is one thing that you can do to test a sensor. You can have it plugged in right here, and if you have a magnet, just run it up and down like that, and you'll see it moving. A little less. I figured they'd be taking it easy on you by now. No mercy. I popped that cover off. I wanted to show you guys something real quick on these pressure control valves. So these little nuts that hold these things on, these are really sensitive to torque. So if you tighten these up really tight, the valve won't work correctly. So there is a torque spec. If you have an issue with a clutch valve that's not working, that might be one thing to check. Is it one of these components or some frac hand in there with a hammer and tighten it up? Okay. So next we'll pop this clutch inspection cover plate off and take a look at the clutch. Show you how to check that out. Okay, so that plate, sometimes it'll still, they change the round and cut that one off. Pops right off.
Just looked at it.
It's kind of a letdown, isn't it? You guys are ready to start swinging on things. So we're looking at the clutch drum, right? So this is your K1 clutch, the big one, the outside, right? And these are your K1 clutch discs. And you'll see that. You can just see those around. That. Okay. You can just move those. And there is a specification and a tool. It's just a piece of metal that we shove down in there to measure that distance.
Is it go, no go?
Yep, go, no go. And this is normal. This is what you ought to see. This is perfect. After a while, after some heat, they're not going to move around so much. But you should always be able to move them around. And if you ever get ones that are just absolutely, you can't get those to move, your clutch is cooked. The other thing that you'll see, again, is these, they'll go from this nice little gray to black or blue, red, and all that stuff. Especially this inner drum. This is your K2, right? So this is the one that we start on. This is the one in starting is where you get all slipping. But in order to inspect that K2 clutch, you're going to have to turn it. And it'll turn pretty easy right at first. And it's luck of the draw. And both clutches are turning at the same time. So but when it's installed, and this isn't going to turn because it's coupled into the engine, then you have a little better luck of getting the two clutches to turn independently. But that's all you have to do is keep turning until you get a window. And then once you get that window come up, then you can get the other clutch drum in through that window. And it's the same. Same thing that we're going to look for is if you can move those clutch discs in and out. And again, if you're looking for signs of heat, it should look nice and gray like that. Shouldn't be black or red or purple. To get the clutch out, you pop this off and then flop it over and set it up on its face right here, and then pull the clutches off from the back. And whenever it comes time to do it, we'll come and help you out. The clutch is in a normally released position, right? It's held open by spring pressure, really a lot of spring pressure. Almost said one of them words. And you have to release that spring pressure. So that what we've been doing is just using a series of longer bolts taking all the bolts out except for a couple and putting a little bit longer ones in, you know, and then popping them out and gradually working it out. It takes a while. It's about maybe like a ½ inch, 3/4 of an inch that you gotta back out under spring pressure. And then once you get that off, all the plates just lift right out.
What time frame are you looking at, like changing the clutch?
Well, we're shooting for midlife. The end game is the clutch will last the life of the transmission. But there's a lot of tuning that needs to go on with the clutch to make it live longer.
And operator error too.
And you got operator error. But from what we've been seeing so far is we're not seeing wear so much on the clutch, as we're just seeing it flat burn out. And then when it burns out, those plates warp, and then it gets to the point where it drags so much that it can't synchronize, it can't shift gears because it can't slow the other shaft down to put it into gear.
What's the time frame on that you're seeing these failures start happening?
The first couple that happened within the first couple of days, and that took some tuning, some program changing, and since we've done that, we don't know yet. So the newer ones that are out, we've got one that's up as 3,000 hours ish, and it hasn't fried yet. So we'll see. Next, the transmission oil flow, basically, just like anything else, right? We're going to pull oil out of the pan through the pump, pressurize it, send it to the filters. It's going to go through the filters, and then from there, then it's distributed through the transmission. The hydraulic circuit, 500 to 600 psi. That's what actuates your shift rod, your shift forks, your clutches. The actual lube pressure is 50 to 60 psi. So there's two different circuits, there's two different oil pressures. Again, it's going to go through all these manifolds, it's going to split up 100,000 different ways. It's a mess, it's a lot to look at. All the steel tubes that we looked at on the outside, that's your actuation lines, you see those. Lubricating oil flow is all internal through drillings. Clutch manifold, high volume, lots of oil goes through there. A lot of oil needed to actuate those clutches and to cool those clutches. And then it also is the oil supply for the PTO gears. So that's the gears inside the PTO pods. Remember that the actual drive themselves, it's dry. There's no oil out to the drives. Tops manifold, cooling oil. So this is oil that's going out inside the transmission and spraying oil on the gears inside, cooling oil. Handful of those outside too. Holding brake. So next we'll talk about normal operating parameters, procedures, things that you're going to see. Main system pressure, again, 500 to 600 psi, depending on the temperature of the oil and what it's doing. Lube oil, 6 to 12 at idle, 45 to 55 at rated speed. Transmission temperature, these transmissions run a lot cooler than the competitive transmissions. There's no torque converter. There's none of that grinding and slipping that goes on in a regular automatic. So your normal transmission temperature will be 150, 160 degrees. Doesn't need near the oil cooler that the other transmissions do. Operating techniques. This is for the operators out there. This transmission is different than the other ones. There's no, I want to start out fourth gear. There's no, in first gear, I want to go fifth gear. Everything has to happen sequentially. So if we want to start out, we have to start out first gear, and then we have to shift first, second, third, fourth, all the way up to whatever we want. So even if the operator, if he selects fourth gear and throttles up, it's going to go to first gear, and then it's going to shift its way up until it gets to fourth gear. If he just selects fourth, it'll do that by himself, or he can sit there and push buttons all day long if he wants to. Same thing with shifting down. It has to sequentially come from fourth gear down to first gear if they want to go down that way. But neutral is just a clutch release. Hit neutral, releases the clutches, shift forks go back to the home position. When the shift forks go to the home position, the TCM waits until it sees 15 RPM or less output. So if you're watching it on PUTTY, you're watching it neutral, you'll see your shift forks wherever they are and you command neutral. You'll see everything will stay there. until the shaft speed gets down below 15 RPM, and then you'll see everything settle back into home position. Should be shifted to neutral before you shut it down. If you don't, if they just power it off, if it's in fourth gear and they just power it off, it's going to stay in fourth gear, right? Because everything's hydraulically actuated. So when they start it back up, it's going to still be in fourth gear. And once it builds hydraulic pressure, it'll move everything back to the home position, neutral, ready for first gear. When they're starting out against well pressure, again, we start in first gear, we have to start in first gear. The higher the well pressure is, the higher the engine RPM has to be before it's going to engage the clutch. So if there's zero well pressure, they push first gear, the engine's at idle, it's going to grab the K2 clutch and you're in gear. If you got 5,000 PSI well pressure, you're going to have to throttle it up to, I don't know what it is, probably 1,300 RPM, and then it's going to engage the clutch. Okay, because if we engage the clutch at idle against well pressure, it would just stall the engine. So it's just like driving your truck. You've got a big old trailer on it, you know, with a manual transmission. You got to rev it up and slide the clutch out to get going. Most operators, they probably won't really notice that unless they're really paying attention. If they select first gear and then they throttle up just like they always will, they're not really going to notice that it's actually in neutral until it gets up to 13 or 14 or 1500 RPM, whatever it needs to be in order to lock in at that pressure. But some of them have complained that when they put it in gear, when they've got well pressure, that it's not in gear until they throttle it up. That's normal. And that's changing. We have a sheet right now that says at a certain well pressure, we need a certain RPM to engage the clutches, but it'll probably change next week or the week after as we get more tuning. So there is no neutral, okay? The transmission doesn't shift to neutral. We just release the clutches. Again, if it shuts down when it's in gear, it's going to stay in the gear that it was in when it shut down. And then another thing, if it's been setting for a long time, or if you do some kind of service and you have lines off, even if you do an oil change and you have a chance of getting air into the system, it's a good thing. Start it up and just bump it through the gears. Make sure you push all the air out of everything. Do that a couple times. Once you see everything's working fine, you can let it go back to service. Again, go to neutral. If you've got your computer there, make sure everything goes back to home, minus 97 and 97. Okay, maintenance stuff. Uses the same oil as you use in the engine, 1540 diesel oil. Pumpco is using 30 weight transmission oil. They're the only ones, and that's all done under an agreement. We're doing weekly oil samples. Right now, we don't know how it's going to work or if it's going to work. So just a rule of thumb, it's 1540 engine oil for everybody else. 40 gallons, 65 gallons fill capacity. Oil level, checking oil level. So there's no dipstick. There is the deal, the electric deal. You can watch it putty, but obviously the good way is with the sight glass. Quick and easy. With the engine running at idle, the oil level should be at about the parting line where the oil pan bolts up to the transmission, to the gearbox. So when it's shut off, when you fill it up, you do an oil change, you fill it up, it's going to be, you're going to pour oil, it's going to be plumb to the top, even beyond the top of that sight glass. Start it, run it, let everything circulate through, and then it'll drop down. And eventually you'll get to the point where it's running at that parting line. The filters, so these are just regular Parker hydraulic filters. They are under pressure, 500-600 PSI, going through those oil filters. 500-hour oil change interval for now. We do have them in stock. We have seen on a few of them at fairly low hours start to give us oil pressure calls. It's because these filters were plugged up. So not sure yet if that's trash in the transmission, trash in the oil. And all the oil goes through those filters, so expect, that's the other thing, if I was going to go out on one of these, I'd carry a handful of filters with me. We're going to see a lot of filter plugging, I think. All right, 2 breathers in the side of the transmission, we saw those. That's a maintenance item. Change them every 6 months. Pretty much the only thing that we notice on that is that those start to get plugged up. You'll start seeing that the sight glass, the oil shows low in the sight glass. It's because the transmission can't vent. Take those vents off or take the oil fill cap. the oil comes right up. So every 6 months, change those. Okay, so now we'll start talking about the putty, the fun stuff. Okay, so to talk to it, that's the cable you need. You saw it out there. That's the part number. We have those in stock in Arlington. I think it's $80. And then, like I said, Wayland's got a couple of them, but you guys ought to probably each get you one and keep it with you. So that way we can roll you out at midnight. Connector location, we saw that on that front cover plate there, the bottom one you saw where I'm plugged into it. That's where the house plugs into it, or the rig house. And then the cable that hangs down, that's the diagnostic. Okay, putty. So this is the diagnostic tool. This is on your computer. Every one of these computers that came out, it's on there. You shouldn't have to download it. You just have to find it. It's really a simple program to use. It works really fast. It's nothing like Insight. It doesn't lock up all the time. It's really good. It's really easy. It's user friendly. We'll get you set up on that and we'll walk through it. So this is the home screen. You connect to the transmission. You hit backspace, and this is the home screen. This is what you're going to see. There's 8 screens to look at: inputs, outputs, the data link, alarms, processes, tests, calibration, and runtimes. To go to a screen, whichever one you want to look at, if you want to look at fault codes, you're going to push number 4, hit enter, and that'll take you to the fault screen. So the first screen is inputs, out and 1. Here's all your pressures that we were talking about: clutch pressure, clutch 1 and 2 pressure, oil level transducer, 100%, it's full of oil, lube oil pressure before the filter, lube oil pressure after the filter, temperature before and after the clutch, sump temperature. Here's all your shift fork position sensors. What gear is this transmission in right now? Home position. If it was commanded in neutral, it would be in that position. The clutch is released, ready for first gear. Input shaft speed, output shaft speed, clutch speed. Probably what you're going to look at the most on this is shift fork position sensors. Transmission won't go into gear. You're going to go here, you're going to see R7, R8 floating around at 50 or 0 or whatever, because they tried to go in tops and it wouldn't go home after that. Everything's in PSI, temperatures are in Celsius, 100 to minus 100, we talked about that. CAN bus, this is for the engineers. I don't know what use you or me or any of us would ever have with this screen, but if you've got a communication problem or something like that, one of the engineers might ask you to go to the screen and tell them what these numbers mean. But for the most part, you're not going to use this screen. All right, screen 4 is the fault screen. When you first go to the fault screen, these are going to be your active alarms. The faults come up as SPNs and FMIs. Okay, there are Cummins fault numbers associated with these, but this doesn't show them. This will show you the SPN, the FMI, and then a description. There's no timestamp, none of that. It's just going to be a fault, what the fault is, and a description. So using your arrow down key, if you arrow down, you go through all those active fault codes all the way to the bottom, arrow down, and that'll take you to the inactive faults. Inactive faults, we can't get rid of them. They're there forever. And again, there's no timestamp on inactives either. It may or may not be useful to look at that, because you're going to go into inactive, you might see a fault that's 2,000 hours old and you wouldn't know. Again, this page is for the engineers. There's nothing here that you're going to be able to use. It's just telling you what gear it wants and what gear it sees, and how much the clutch is slipping. Test screen. This is one of those screens. I don't even know if I should do this, but don't use this screen. Okay, this screen, only use this if someone from my team or someone from engineering is telling you try this with this screen, because if you do the wrong thing in this screen, you can cage the transmission, tear things up. So literally what you're going to do on this screen is R1, R2. If you go in here to where it's 0 and you tell that, you tell it 0. And then you hit enter. Well, it's at minus 97. It's going to move it to 0, which is in its position. Right? Or you can tell it to go 97, which is all the way to the other way, which is all fine. But if you got something hanging up, like that ProFrac one the other day, the fudge was hung up, if you tried to move this, you're actually shifting gears when it's not supposed to, and things will clunk and grind. And you can move things around in here and cause problems, so. Unless somebody tells you to do something here, don't do it. Oh, look, it even says that. Okay, calibration screen. You'll use this one a lot, okay? If you go out to one and you have a shift fork position sensor that is reading some stupid, sometimes you'll see them minus 31,658. And usually that means the sensor's trash. But we always want to try to calibrate it first, see if we can bring it into range, see if that'll fix it. And also, if you put a new sensor in, you have to calibrate it. So you just go to this screen and using the arrow down key, you just arrow down until you underline whichever one that you want to calibrate. And then you push enter. And then when you push enter, it'll say that it's calibrating A, and then you'll see it, it'll actually move. It'll start moving the shift fork, and you'll see it move all the way down to 100, and then settle at 97. And then it'll go to B, and it'll command it back the other way. So it'll stroke it all the way one way, and all the way back the other way. And that calibrates it. If it ends at 97, minus 97, you're good to go. You fixed it. Transmission has to be running, obviously, to do this. Everything's hydraulic. This screen, you'll use this a lot. Screen 8, runtime. We'll ask you for this a lot. And this is, as you can see, it's hours, total hours, hours and neutral hours in each gear. We'll do that. Once we get done here, we'll go out with my computer. We'll plug in with my computer, and I'll run you through that, and then we'll do it on yours. All right, so show you guys a couple of things about connections real quick before we do this, and then we'll hook the batteries up and we'll connect the laptop to it. So inside of here, remember this is our customer connection, right? So there's a ground bar in here. Okay. This ground is critical. This needs to be grounded, preferably straight to the batteries. But if not, it needs to be a good chassis ground. So if you do have a connection problem, check this ground. And it's an OEM connection. Several connectors on here. The one that we want to use is the RS-232 connector. Okay? None of these other ones will work. And the way that we're going to set up these laptops is to work on this port right here, the one closest to the charger port. And that is COM1 port. So it's just as simple as plugging that in. If you've got a little pocket screwdriver, that's the best thing to do. But oh, look at there. I knew somebody would have one. Okay. So I got the putty deal set up on my taskbar, and it just pops up. Okay. So part of what we're going to do when we we're going to set up all the parameters in your computer just right and load it as a session, right? So when you go in, you're just going to click on the session that you want to use, which we have this one, it's called QTR, and then hit the load button. And now that sets the tool up the way that it needs to talk to this transmission. And then you push open, and then you push backspace, and look at there, it worked. So once you push backspace, now you're connected to it, okay? And then again, whatever you want to look at, like we want to look at fault codes is screen 4, push 4. And now here's all the fault codes that we have. These fault codes are active right now, and if you look at them, these are all temperature faults and a pressure fault. There are several faults that come active with cold oil, And it does show on it shows on the screen in the data van, it shows as a fault code. It doesn't show warm-up mode. It'll show a fault code. So a lot of times the operators, they think there's a problem.
So we'll get a lot of false calls?
You get a lot of false calls. So the one thing is ask them, what fault code are you seeing? Because I've had them call me and say, hey, I got an oil pressure fault. Oh, you do? Yeah. Well, tell me what fault it is, and they'll read it off. No, that's oil temperature. Let it run. Right? There is a warm-up mode. The transmission, when it's in warm-up, when it goes into warm-up mode, sort of like tops, it needs to see 0 shaft speed. So you might have to set the brake if you've got a little bit of drag. Set the brake, it's going to automatically go into warm-up mode. And what it does to go into warm-up mode is it cages the transmission, throttles the engine up to about 800 RPM, and then it just starts kind of pumping the clutches, dragging the clutches just a little bit. Friction on the clutches heats the oil up. And it keeps doing that until it gets the oil up to about 86 degrees, and then it's ready to go. So that's what we need to see, 86 Fahrenheit oil temperature to run. Arrow down, previously active. So there's all the fault codes that this thing has had on it. Again, this is some of what I did yesterday, going around unplugging sensors and making things happen. So your field hands are going to do that to you. Backspace to get back home. Screen 1. Here's all your inputs and outputs. Here's everything doing. There's your shift forks at 97 and minus 97. Shaft speeds at 0. So if this thing was running right now, with those position sensors in that position that they were in, and your clutch 2A pressure was 500 psi, you should be in first gear. You should have output shaft. If your clutch pressures are both at 1 or 0 or whatever, you're in neutral. It does have a reading to show you what gear is requested and what gear it actually is. And that will show 1 gear more than it is. So when it's in first gear, this will show 2. And there's a reason for that I'll tell you when we're offline. Because there's a secret gear. Again, the data link, you'll never use that. Shift fork position sensor calibration. That's the one that you're going to use a lot. Just push 7. You can see it's underlined, so that's the one that you want to underline, or that's the one that you're going to calibrate right there. If that's not the one, you just arrow down till you get to the one that you want to calibrate. And then once you get there, you just press enter, and then it does it all by itself. And then once it's done, it says done. Okay? And then the other thing, which run times, but you saw that it's no different here than it was there. That's another good one to look at. That's it. There is no, do you want to disconnect or any of that kind of stuff when you're done? Unplug it, turn it off, whatever. It doesn't care. The TCM doesn't care. The laptop doesn't care. But if you want to do it proper, you push OK and do that.
Is there a way to like save an image? You just gotta screenshot it.
Yep.
Oh, there is.
Yeah, that's the image saver right there. Yeah. Yeah. Little troubleshooting and diagnostics. Okay. 19 sensors and actuators, 1 control module. But again, all the actuators, all the sensors and everything, the harness is tagged, what that sensor is, and the housing is stamped, what that sensor is. So pretty easy to find. Just some of the abbreviations, just because it's different, right? Some of it's kind of obvious. Pressure sensor is PT, pressure transducer. PCV, pressure control valve. PRV, pressure relief valve. Pretty simple, but different. But again, your fault codes, if you have a fault code for the brake valve, SOV, BRK, that's what it'll say, SOV, BRK. shorted low or whatever. So you need to learn this so you know what it's talking about. Pressure sensors, it's all the same as your typical Cummins sensor, and some of the sensors that are on the engine are Cummins sensors. They are Cummins part numbers, and some of them are dash part numbers. Pressure sensors, position sensors, and actuators, that's all stuff that's different and it's new. Really, the only difference between the transmission pressure sensors is they're just working at a higher pressure, right? Again, we're back to the 500-600 PSI, right? And we're used to 0 to 100 unless we're into fuel systems. Position sensors, 100 minus 100. Okay, we went through this on the computer. We'll go through this again once we get your computer started up. Faults are the same on this as they are like on an engine. If you unplug a sensor, it'll say shorted low, right? Same as an engine, shorted high, shorted low, all that stuff. So the troubleshooting that you use on an engine, you can use it on this. SPNs, FMIs, there is a conversion. Every fault code on here, most every fault code on this transmission has a corresponding Cummins fault code. So you can go into QuickServe, you can put in type fault code 8034 and get troubleshooting steps for this transmission. And I'll show you that here in a bit. So on QuickServe, it's going to show on this just like it does on an engine. A little diagram, what to do, what to check for it. Code information, same thing. And then that's that. That's the end of the presentation.